How's everyone doing? We're just getting started here. Today we're gonna be attempting to learn Go. I'm familiar with it. I've not written any code in it. I've not really helped anyone write code in it. But probably for the last 2 years, I have been following Go. I listen to like the Go Time podcast weekly. And I keep up with the news in the Go universe. So I'm not entirely unfamiliar with Go. So I don't anticipate this being incredibly difficult for me. And we're just going to be making Tic-Tac-Toe, a simple command line game. It's not going to be anything complicated. It is going to be it's going to be my submission for this week's Summer of Code, Beginner.Code Summer of Code challenge, which is to create a 2-player Tic-Tac-Toe game. Doesn't matter how you implement it. Just needs to be a 2-player Tic-Tac-Toe game. One thing that's going to be interesting here, Go is a little less object-oriented than Python, and I tend to like my object-oriented programming. Go isn't entirely object-oriented. It's not like a purely functional language, but it leans more in that direction. You don't really have like classes in like the keyword sense. So it'll be interesting to see what happens. I've never installed Go, so I can't compile Go right now. I can't run it at all. So we're gonna be starting from zero here. I think my game plan is gonna be to go to the Go website and see what they say for getting started. So yeah, this should be fun. So like I said, this is just gonna be like a 2-player Tic-Tac-Toe in the command line. So like my game plan for writing it is gonna be, I need to have a way to represent the matrix, the 2-dimensional 3x3 board. So we've got to figure out how do we do that. We're gonna need to keep track of what is at each spot. Is it empty? Is it an X? Is it an O? We have to keep track of which player's turn it is. So we're gonna need a way to do that. And then we're gonna need our game loop. So we're gonna need a loop somewhere in there to loop through each turn. And then I'm going to need to come up with a way. It'll probably be just like a function, something like that. That will check the horizontal, another one that checks the vertical, another one that checks the diagonals. So that's pretty much what we're looking at. It should be pretty simple. Probably the biggest thing, hardest part tonight is going to be getting Go working in VS Code. Just figuring out that process of creating an application and running an application. This should just be like one file. It's not going to be anything crazy. I think I usually stream for 2 hours on Wednesdays, so we should be done by the end of that 2 hours. That's my hope. That's my thought. And that's the goal. Right now, I've already got a GitHub repo created. The link is down in the description, so if you ever want to check it out, you can do that. And a little bit about me for anybody who might be joining, who doesn't know me, isn't familiar with what I do. I am the admin for the Beginner.Code's Discord server. We're just over 8,200 members at this point. We help people with just about any coding questions they might have. It's geared towards beginners, as the name might suggest. It's not the world's most active chat server. Like, the general chat isn't super busy. But the help channels get a lot of action. We have a really good system for organizing it by language, by topic, and making sure that questions that you ask aren't going to get lost in a deluge of comments. So yeah, if you aren't a member and you're watching this stream or you're watching this video after the fact, be sure to check out the link in the description below and join us there. We'd love to have you. If you've got any questions for me, you can reach me on Twitter or in the comments below or on the Discord. I'm most active on the Discord. I do check my Twitter all day long, though. I'm not the most prolific tweeter, but I do check my Twitter all the time. So yeah. All right, let's get started. I think what I'm gonna do to get started here is I'm gonna find the Go website. Well, that was not what I meant to click. All right. I think that's a good term to start with, right? Go.dev. That seems like the right place to go. Let's get started. Install the latest version of Go. Review this install documentation. I'm wondering if there might be a homebrew way to do it, or do we just download it? I guess we can just download it. Worst case scenario, I'll uninstall it at some point and install it a different way that I like better. All right, so let's get started with that. That package is downloading. So like here we go. It says Go install. Select the tab for computer's operating system. All right. Verify that you've installed Go. All right, there we go. We've got the package. So we're going to install that, and then we'll be able to run Go version in our terminal. Hopefully. Hopefully that'll work. All right, install. There we go. It's going pretty quick. We shouldn't be waiting too much longer. Any second now. This is compelling content right here. Me watching a progress bar go across the screen. But yeah, this should be fun. It should be pretty simple. And it got stuck. Oh, let's see. All right, so, here we go. We've got a getting started tutorial. So what do we got here? Bring this over here. A little bit more. Whoa. Put that in the middle. Brief introduction to Go programming. Along the way, you will install Go, write some simple hello code, Go command to run your code. It's going to show us how to install packages using the package discovery tool, and how to call functions of an external module. And they have other tutorials right there if you ever want to check those out. Alright, so let's see here. Pretty simple code. Helps to know something about functions. Functions aren't too complicated. I think we'll be fine. We're going to use VS Code. There we go. Yep, VS Code. I would like to use Golang because it's by... who is it by? It's by, I'm blanking on it. But it's by the same people who make PyCharm. So, I contemplated attempting to do this stream, like, using NeoVim or something like that. But, like, I would have to learn Go and NeoVim, and I decided that was a bad idea. So, we're not doing that today. Maybe one of these days, I will attempt to learn NeoVim on stream or something like Vim. I'll have to look into it. Primogen has a lot of Vim content. I'll have to check out what he has. And let's move that package installer to the trash. And Go, nope. Source. Go. Let's see. I want to do that. Terminate. Kill that. And let's bring up the terminal again. Let's see if this. There we go. So let's see. We want to go to projects, YouTube. Did I have uppercase here? That was weird. YouTube, Go, and then we're at Tic-Tac-Toe. There we go. And we're back where we need to be. And let's get this window back to the way it was. Excuse me, choking it out here. Alright. So we're just gonna follow this real quick. Alright, enable dependency tracking for your code. Alright, let's see what that means. When your code imports packages containing other modules, you manage those dependencies through its own module. That module is defined by a Go mod file. So let's run Go mod init. Let's see what that does. Whoop, if we spelled init correctly. I missed something, didn't I? Oh. Okay. So let's see. The name is the module's module path. So I feel like this might actually be so now you've got to go mod file. Module hello world. It's a require go 1.19. Okay. Alright. So if you're familiar with like poetry in Python, this is kind of like your pyproject.toml. So it's going to store information about your project, about your module, like what it depends on, what projects, packages it depends on, the name of your package, what version of the language it requires. So yeah, it just helps make everybody's environment consistent. So like if you create a package and you share it with someone else, they can install it and get all the exact same dependencies. It'll make sure they have the correct compatible version of Go. So yeah, that's what's going on here. Actually, let me do this. We're gonna do... Well, no, we're gonna leave it there. We're gonna leave that. In your text editor, create a file hello.go. There we go. So now we've got a Go file. Let's install the recommended extensions. Installed. There we go. We're good to go. Okay. Install that. Installing. I'm assuming it's still installing. This is why I generally don't use like the built-in terminals and stuff. I guess we'll just assume it's working. Like the settings, maybe? I don't know. I don't use VS Code very often. I'm just using VS Code because I feel like it'll probably do a better job of like handling Go than PyCharm would. I'm much more familiar with PyCharm. I'd be much more comfortable doing this in PyCharm. I just don't think it would work out as well. Create file hello world to go. Paste the following code in your file. Well, that's boring. Copy paste. How am I supposed to get syntax errors if I paste all the correct code? And then I'm assuming we're gonna just like go run this. Yeah, there we go. Go run dot. Go run dot. Boom. It worked. There we go. Very cool. Alright, so we've learned one thing. How to print to the screen. Alright. Call code in an external package. I don't think I'm going to need this tonight. But it's useful information. And like we're trying to learn Go, right? A little more interesting, the function for an external module. Just out of curiosity, let's see what their package website looks like. Very fancy. I feel like this might be a language developed by people who work for Google. We got a search bar right in the middle of the screen. And what packages do they tell us to install? Let's get rid of that tab. And we're going to go to quote. And I think that's the one they wanted. Said to ignore V3. I see V4. What am I doing here? I feel like I don't have to do anything here, right? Oh, well, I'm confused. Alright, go back here. Oh, they just want us to see under index the functions that are available. So like just basic documentation is here. That's handy. Like that. Oh yeah, right there. This is documentation. At the top of this page, note the package quote is included in the rsc.io quote module. I'm not sure totally where they want me to look. I see RSC quote all over the place. So sure, yeah. I guess it's from there. You go quote, import the RSC IO quote. So like here's how they're doing the import. And then we're gonna print line quote.go. And like if we look back, we're already doing print line. So we're just calling a function. What is interesting to me is that like it's a URL, but the import is just quote. So I'm a little curious how that functions. So there we go. Did I miss a step? Why is this yelling? So we import it, and then we go mod tidy. Let me just add a usage for it. And then it was quote go. Alright. So we got auto formatted there. Okay, so that's automatically again. Alright, and so now it's not. That's an interesting way of doing things. I'm gonna be honest, I'm not a fan out of the gate here. Just because I don't like my IDE to tell me my imports are wrong. But it's an interesting system, and it works. It has the nice advantage that you don't have to add all the files. You can just import them and then run your tidy command, and it'll pull everything in for you. And now I think we should have some more files. So now we have, so if we do go mod, now we see it now requires that package. And then it requires this package indirectly. So that's telling me it's coming from this. And it requires sampler. So it requires text indirectly and requires sampler indirectly. So those are coming in as requirements of quote. All right. And then there was another file. We have go.sum. We can do go.sum. And so what we see here, these are the checksums for, like, you see here's one package, and here's a checksum. There's probably two files here. It looks like there's two files because we've got one line that is the checksum, and then there's the go mod file that appears to be for the package, and that has a checksum as well. You can see the hash right there. I'm gonna assume that's the algorithm that's used for the hash. I'm not sure. Interesting, but yeah. Python, like poetry for Python, does the same thing. If you ever look at your poetry.lock file, you're going to see a lot of these hashes in there if you scroll down. So yeah, it's a common pattern, and it's becoming more common for more languages. Like, it's definitely something. I think Node does the same thing. I haven't looked at how they structure their stuff, but I'd imagine they do checksums as well. Just for validity checking. It lets you verify that the package that you downloaded is the same package that you downloaded the last time. The same package that you downloaded when you installed it the first time. Alright, so now we can go ahead and go run dot, and that will run our hello pack. So I think if we run this, nope, it's going to keep giving us the same message. Okay, all right. So it's just printing out a message. And if we go back to Chrome, and then there we go. All right, yep, it's showing the exact same message. All right, cool. I don't want to create a Go module. But what I do want to do, let's try and figure out how do I... Alright, what do we gotta do? We gotta figure out two things. How do we make a grid in memory to store the values on our board? How do we create a variable to store whose turn it is? How do we create a loop? This is more than two things. You need to figure out how to create a loop. I vaguely know I could probably poke it enough right now to figure it out, but we got to figure that out. And then we have to figure out how to get input from the user. So this way we can get what square on the board, on the grid, they want to place their X or O, depending on what player it is. Tutorial getting started, create a module. Okay, so alright, so we did want to go to the next one. Introducing functions, error handling, arrays, maps, unit testing, and compiling. We're not going to be writing any unit tests, and Go run is fine. Go is kind of unique, I think, in that you can just run Go code as if it were interpreted, and then you can also compile Go code. Just like a normal compiled language, which is kind of interesting. So we're going to go ahead and click on that one. It was the next one, so we could have just kept going. So we're going to create a function, hello. Alright, so what exactly are they doing? Alright, open command prompt. Alright, so they're just creating an all new module here. So I think what we're going to do is we're going to delete everything except for license. ROM, alright. Nope, that's wrong. RM, there we go. We'll delete that. And then we're going to do rm dot go. There we go. Alright, so now we have no extra files in here. And we're going to go ahead and we're going to create a module. Now, it looks like, to me, like you see right here, we have example.com/greetings, right? So I believe that's like our namespace. So, like, if we were to publish this package, this module, that would be like our username on package.go.dev. Of course, we're not going to be publishing this. Right, so we've created our new module, and we can see if we do cat.go mod, and there's all the information. Paste the following code. And like one thing I'm noticing here, let's create a new file. It was greetings.go, right? Yeah, I believe it's greetings. Yep, greetings. Greetings.go. And now if I were to try to see, like, does this let me can I just run the file? I don't want to debug it. If anybody knows how to run a file in no, that's not what I wanted. Interesting. Yeah, I don't want to debug anything. I just wanted to run it. Hold on. We don't have to worry about that. Because we could just do go run dot. Is not a main package. Interesting. So let's see. Do the instructions have another step for us? This is the first code for your module. It returns a greeting to any caller that asks for one. You'll write code that calls this function in the next step. In this code, you declare a greetings package to collect a related function. So like right here, we're declaring the package. And then you implement a hello function to return the greeting. Right there. Alright. Takes a name parameter as a string. It returns a string. In Go, a function whose name starts with a capital letter can be called by a function not in the same package, known in Go as an exported name. And then they have more documentation for exported names. And then they explain the structure of a function. So like you have your func keyword, and you've got your name capitalized, so it'll be exported. Give your parameter name, and then the parameter name's type, and then this is our return type. And then you create a block with the curly braces. Pretty simple stuff there. I think anybody familiar with already familiar with another programming language is probably going to look at that code and have like an 80% understanding to a full understanding of what they're looking at. It's pretty straightforward. So yeah. In Go, the walrus operator, assignment operator, is a shortcut for declaring and initializing a variable in one line. Go uses the value on the right to determine the variable's type. Taking a long way, you might have written this as... Oh, okay, I see. So you can use var message string to declare that you're going to have a variable. And then you can do just a regular equals assignment later on to assign a value to that variable that you just declared. That's how you can do an assignment. And you can use the walrus assignment operator to do all of that on one line. And then they're doing sprintf. Sprintf, S is standing for string. So essentially you're printing into a string rather than into standard out. That's the idea behind that. It's handy because you get the same functionality as print, but you get to store it into a variable. Provides the same basic interface as print. Alright, and then we'll return. Okay. Call your code from another module. So now we're going to have to create another module. We're going to create a hello directory for Go module source code. This is where you'll write your call it. Interesting. So maybe we need to enter greetings. Greetings.go into greetings slash. So now if we do that, so now we have that. Hopefully we did this right. We'll find out in a minute, I think, right? Like, cause here, start your mod init command. Like it didn't. Okay, create a greetings directory for and cd into it. All right, so we probably need to move go mod into greetings. We'll figure this out. There we go. So now we've got nothing here, and then if we, there we go. Got all of that. So let's go back to here. So we're gonna do the same thing, but this time we're gonna create a folder hello. Boop. Missed the M. And then going to create a file in here. New file. Hello.com. Alright, and then inside of that, we're going to paste our main function. And this is going to be package main. Even though we've named the file hello.go, like if you go over to greetings.go, you see the package is greetings, the file is greetings.go. Here, it's hello .go, and the package is main. So that's telling it's the main package. This is complaining right here. All right. Oh, you know what we did? Did we not do this? I don't think we did this. I think we did it. So we'll go ahead and do that. Interesting. So I can't find it. 404 not found. Okay, interesting. All right. So I guess we'll have to figure out what the next step is. All right. We declare the main package. We import two packages. So we've done something wrong because it seems to think we should have access to the hello function. But VS Code seems to disagree. So oh wait, here we go. So here it's saying, typically for production, you'd publish the greetings module with a module path that reflected its published location, where GoTools could find it to download it. Because we haven't published the module yet, we'll need to adapt the hello module so it can find the greetings code on the local file system. To do that, we use the go mod edit command to edit the hello module to redirect Go tools from its module path with module isn't to the local directory where it is. Okay, so yeah, I was right. There was something iffy happening there. Okay, I see. All right, so we see what's happening here. We're telling go mod to replace the example.com/greetings package with this relative path. So we're currently inside. Well, we're not yet. Oh, I goofed up. All right, so let's fix the goof up. I don't know if anybody sees the goof up just yet. If we can get rid of this line. We are currently in the Tic-Tac-Toe line. And I have my go mod file here. So let's rm go mod file, and then let's ls or cd into hello, and then we go mod init. There we go. And then we go mod tidy won't work, and then we do go mod edit, and that'll edit the file, the go mod file. Yeah, there we go. See, so added the replace line to our go mod file, and it tells it to look relative to this folder to go up a directory and then into the greetings directory. Okay, so if I come over here, it still complains, but what can you do? I don't know why it's doing that. Command specifies example. All right. Yeah, and here it's showing what I just showed by catting the file. All right, so we have to run. Oh, okay, we have to go mod tidy. All right, cool. This time when we ran it, it found example.com/greetings. It's interesting that it says that it found it in example.com/greetings, even though it didn't. We just replaced the location with an on disk location. On the tidy command, and so now if we do cat go mod, now we see we have the require for it. Very cool. So it generated a pseudo version number. So now we should be able to do go run. There we go. So now it works. So now we're importing a module that we already have, that we created, and we're using it in our main module, our main package. It is interesting that VS Code is still complaining. Interesting. All right, so what's next? Congrats, you've written 2 functioning modules. Turn and handle an error. So errors is a package that we can import. That's a built-in package. And like, here's an interesting thing. Like you see right here, I'm gonna make this a little bit bigger. Make it a little bit wider. So right here we can see they've changed the hello function in our greetings package to return a string or an error. So it's a union operator, not a union right there, a union type of string or error. It's not even a union type. Okay, all right. So it's just a multiple return. I wonder, I don't feel like that's tied to just errors. I feel like you can probably return multiple items. But in this case, they're using it to return an error type, if there's an error. If no name is, so like here, they're checking if the name is empty string. If it's an empty string, then they return an empty string and a new empty name error, which is pretty interesting. And then it does the same thing. And instead of returning an error as the second return value, returns nil. All right, pretty interesting, pretty cool. So we'll go ahead and update that file. Come over here, and we're gonna go greetings.go. I have a feeling we're gonna have to. Okay, what is VS Code complaining about now? Why is it saying there's a problem there? Okay, why? There we go. Okay. Out of curiosity. Okay, so it ran that code before. I don't know why it's... Oh, wait. I see what's happening. Accidentally didn't overwrite, but it's still complaining. Okay. Alright. Not there. Somewhere it wants us to put a semicolon. I just don't understand where. Very odd. And now we have to see how to modify our hello.go. So like this is just telling us what I just explained. And now they're importing log. Oh, okay, I see. They're setting a prefix for the log for okay. And they're setting flag 0. Source file line number. I will say, like, I haven't actually used Rust just yet. But like Rust has result types. So you can have like an okay result or an error result. And then it has match expressions. So rather than returning multiple values to handle errors, you would return an error result type. And then you would take that returned result and check it in the return or the match in a match expression, looking for an okay type, looking for an error type, then you'd have the code to handle each type. It's kind of like a switch statement. And I feel like that's a little bit cleaner, a little bit nicer. I think it's a nicer system. This is an equally valid system. It's just you have to write a bunch of extra code because like if you look up here, like we have to there's no error message here, but we have to put nil, right? There's no return, but we have to put an empty string. And so like and you have to declare, okay, this function returns an error type. Sometimes. I'm also not a huge fan of how this error type is optional. But there's no indication of that here. And by optional, I mean it can be nil. I would prefer to not return a type, like error is a type, right? And nil is not an error type. It's just an absence of value. And so like that kind of messes a little bit with my head. But like I said, it's an equally valid way of doing things. And I do appreciate that this makes things a little bit easier to hold in your head and understand and not run into weird issues. Because that's one thing I've run into for a lot of people who are learning like Python, JavaScript. When you have those exceptions that bubble up through your function stack, it can be kind of mysterious why your code broke, where it broke. And so like this right here is a little bit more manageable. It's a little bit more under your control. And like the result type does the same thing. It's all under your control, how it functions, how it works. You don't have something that's just magically ending execution of all of your functions that have been called one after the other until it runs into a try block that just happens to catch the specific error that's been raised. And like, for sure, this is going to make things a little bit more complicated in that getting a stack trace is going to be a lot harder. So figuring out, if you haven't set up your code well, it'll be harder to figure out where the error came from. So like, Python will explode if you don't handle an exception. But when it explodes, it gives you a detailed map to exactly where that explosion started and who had been called, what functions had been called when the exception was raised. So you can rebuild the state of your application to an extent, which can be handy when trying to understand what's going wrong. So this gives you more power and more control and a little bit less, there are fewer surprises with this setup. But you've got to be a little bit smarter with how you handle things. Yeah. All right, so let's see. Let's update our... So like right here, they're setting up logging. They're going to log out information, like log fatal. So log fatal actually seems to do two things. It logs and it ends execution of the program, which feels odd to me because it's doing two things. I would much rather see log.fatal and then exit on the next line. That if condition does two things, but the log fatal function only does one. Oh my goodness, I just realized I do not have the code up. There we go. I've been showing you code that you can't even see. I apologize for that. So yeah, here's where we're at. This is where we're at. Like I was just talking about like the return types here. And like how you have to return nil if there was no error. And then empty string if there was an error, and then you have to return a new error indicating what happened. Which is handy and can be, it has its pros and cons. All right. So now that we've got that addressed and you can see the code that's on screen, let's go through. So they're setting, they're importing log. They're setting the prefix for the log. So when it prints out on the screen, it's going to be prefixed with this string. So we'll know that the log message came from this greetings module, this greetings package. Or actually, we're in the hello package, right? Okay, so yeah, it's just saying, okay. I'm curious if there's a way, or does it tie the greetings, like, is the prefix tied to the module? or is it tied to the whole application? I'm curious on that front. It's possible this is giving you a unique logger. It's also possible it's giving you a global logger. I'm not sure yet. Maybe we'll play with that in a minute. So I'm going to copy this out. And like here's where I was saying, like you have, if the error is not nil, so that means there is an error type returned. It logs fatal, and here it's telling us it prints it to the console and exits the program. But as you can see, there is no code after that comment that explicitly exits the program, which implies to me that log fatal is doing that for us, and I find that a little bit odd. It's not the worst thing in the world. Yeah, I'm not sure. It seems a little bit odd to me. But there's not like a really, really, really good reason why you wouldn't do that, other than in functional programming, in the mental model of functional programming, a function should only do one thing. And this one's doing two. And that's why I find it odd. Just because that dogma of functional programming is a thing in the world. And I would have figured, like, my intuition would have been that Go was following that dogma. So yeah. Alright, so we're going to paste that code into our file here, into hello. There we go. Got that now. Don't know if I have to do anything. So we're just going to go ahead, go run dot, and greetings, empty name. Exit status 1. Alright, cool. So there we go. We've got the error message. Because we did not provide a name right here. We provided it, well, we did provide a name, just an empty string. So yeah. And now I just want to try something really quick. If I come over here and I import, not import, I don't know, log. If I import log, logs, interesting. Why? Oh, but not used. Okay. Of course it's not used. I just imported it. And then we're gonna do log dot. Interesting. Info? No. Log dot. So it looks like there's just fatal. So we can just do output. 1. Output writes the output for a logging event. The string S contains the text to print after the prefix specified by the flags of the logger. A new line is appended if the last character of S is not a new line. Call depth is the count of the number of frames to skip when computing the file name and line number. If long file or L short file is set, a value 1 will print the details for the caller of output. Alright, so let's got an empty name. So we're going to do that, and I'm going to set this to 0. So why is this complaining? Okay, that's just the weird message VS Code's been giving us. Install that. I don't know what you want from me. There we go. Alright, so now I'm gonna come back up here and I'm gonna go run dot. Alright, so now we got greetings. And then if I do, what if I do, come back over here. So I'm feeling like if I do this, if I call this, it's gonna change it globally. Let's do that. And we're gonna run it. Yes, it changed it globally. Interesting. So that's what I was curious about. Was that going to change it globally, or is it going to change it globally? It does change it globally. So I wonder if there's a way to create local loggers. And the reason why I'm curious about that is because if you can have the logger have a prefix for each package, it makes things a little bit easier to diagnose. So yeah. All right, cool. So we've got that working. Let's go back to the tutorial. In this code, you configure the log package. All right, yeah. We already talked about all of that. Let me see. Does it say anything about... Yeah, it tells us that the log package's fatal function to print the error and stop the program. So the fatal function is stopping the program. Already done that. And now we're going to return a random greeting. Alright, so this is pretty straightforward. We're going to call math, we're going to import math random. And we're going to import time. And then we're creating a function, random format, that we're calling and passing return to sprintf. So it's going to generate a random message inside of random format. So we have an array of string types, and we're going to populate it with 3 different format strings. And like you see, each one has %v. So they're going to take the same name parameter, and it's going to get injected into it using sprintf is going to inject the name into that %v. Alright, and then so it's taking this format's array variable, and it's getting a random int up to n, up to or less than n probably. So it's like going to be 0 to n exclusive. So like it's going to exclude n. And then we're going to give it the length of the formats array. So it's going to be 3. So it's going to exclude that 3, and it's going to get a random number from 0 to 2. And like, so that's what it's explaining here. So we're just going to copy that out. Ooh. This is interesting, actually. Func init. That's a fancy one. So I'm assuming init sets initial values for variables used in the function. So I'm assuming when you import a package, it'll run the init function. And here it's just setting the seed on the random number generator to the current time. And that's useful so that every time you run the program, you get a different random number. Otherwise, it would probably be set to like 0 or something like that. And every time you run the program, you'd get the exact same output because it's always working from the same random seed. All right. Let's see if it explains. Yes, Go executes init functions automatically at program startup after global variables have been initialized. For more about init functions, see affected Go. All right, so that's interesting. So it's calling these after program startup. So I'm assuming that's after all imports have happened, and everything is loaded into memory and ready to go. It checks for any init functions, because it's even after global variables have been initialized. So it's not once the package has been loaded, it's once the program is fully ready to go. Probably calling all of these init functions in every package just before it calls the main function in the main package. So that would be my assumption there. I'm sure if you check out Effective Go, you'll find out more. All right. So let's see. I'm trying to think. Let's see if this gets to a for loop, because we need a loop and we need to be able to read input. So let's see if we can, once we get to the point where we can read input, hopefully this tic-tac-toe game is going to be easy enough that we can just throw it together. Because we're an hour into this, and I usually stop at about 7 p.m. Eastern Time. And it's 6 p.m. Eastern Time. So we've got an hour left to figure this out. So I'm going to go ahead and copy this code, and then we're going to run it like 2 or 3 times, and we'll see how things go. And we go greetings, and then we come up here, run verb. Oh wait, what? Did I not copy it? I feel like I didn't copy it. Please copy. No, wait. What? Oh, I see. I see. Did I copy this? I didn't copy this. I need to copy this. And then that what I just copied is it setting the name. Because right here, if we're on line 18 here, you can see it's passing an empty string. So we're going to just put in a name, and then we're going to run it. Great to see you, Zach. Great to see you, Zach. Hail, Zach. Well met. Great to see you, Zach. Hi, Zach. Welcome. There we go. So there's all 3 of the messages. All 3 messages randomly pulled up. And for what it's worth, you could have gotten something equally as random just by, like, let's mess with this. If you did, I think we can do modulo the same way we can in just about every language. Let's see. So rather than doing int n, let's paste this here. Mod len formats. And it's complaining. Mismatched types. So this raises a question. How do we convert types? Let's try this. Is it going to be that simple? Doesn't say that. No quick fixes. Expected. Let's. So now what's it complaining about? Expected. Okay, so that's not how you're going to convert stuff. So interesting, that won't work. If I do dot Unix, and it's still complaining. It's still N64 and int. Interesting that len is returning an int every time. Like, it's Unix is still returning N64. I guess you need a really big int, regardless if it's seconds or milliseconds or nanoseconds. But yeah, you should be able to do mod. I just don't know how to convert types. So we'll go back to the way it was. Just poking around, trying to understand how things work. Please go back to the way you were. There we go. Alright, what's next? We're trying to figure out how to get input from the user. So we can move on to the next thing. We're trying to figure out how to loop as well. So inside the greetings package, we're adding hellos. returns a map that associates each of the named people with a greeting message. So we're taking a names array of strings, and we're returning a map of string keys with string values, and possibly returning an error. We're creating a map. So we got the make. A map to associate names with messages. Alright. And here we go. We've got our first loop. So we're going to ignore the index. Then we get the value from names. So names is the array up here. And we're going to assign that into there. Interesting. All right, cool. Next up, we've got message error. So we're calling hello, which is just the function we already had existing. And it possibly returns an error. And you see, this is how you, like, in Python or JavaScript, when you raise an exception, if you don't handle it, the language propagates that exception up to the next function that called. But Go doesn't do that. So to propagate the exception, to propagate the error in this case, you check if there's an error, and then you return nil error. So you're propagating that error up yourself. You're doing it manually. Like I said, this is a little bit more powerful in the sense that you get full control over what's happening. Like if you've ever used Python and you've wanted to like handle an exception, and you wanted to raise a new exception that was more clear what was happening, you're going to notice that Python is going to be like, hey, this exception happened, and it was the direct cause of this exception. So the exception you raised was caused by the other exception. So Python's going to show you both of them. And like if you keep doing that down the chain, you're going to get a really long list of exceptions and stack traces, all caused by each other. And Go gives you way more fine-grained control because you can change what this error return is. You can return the error that you received, or you can return your own error. So you have a little more control over what's going on. And you also need to be more careful because because you're losing all that context. If you change out that error message, you no longer know where it came from. You don't know what caused the error. You don't know where the error necessarily came from. Like any context that was included in that error is now gone. So you have to be careful. You have to think about how you're going to structure your error system in Go to make sure you're getting all the context and all the information you need to actually understand what happened. So yeah. Let's copy out that. Because it's not really doing too much interesting here. We're just iterating through the names. We're getting a message for the name. And then we're storing that message in the map with the name as the key. What'll be more interesting is how they handle this, how this is handled later on in our main package. So let's come over here. Greetings. This is just going to go, they had it right before init. So we're going to go right here, paste it in there. Did I miss the last line? I did. There we go. All right, now we're going to come back over here. I do find this syntax right here to be a little odd. Not that necessarily Python's type annotation is any better, because like in Python, rather than like you have in Go, you have map and then you have string, string. The same kind of thing in Python would be dict, string, string, like that. I do like having both types inside of the square braces. Personal preference, I guess. But yeah, that's one of the differences there. And then we're going to come down here, and here's where we're going to be getting back the... Well, it's creating an array of names. It's creating an array of names. So let's copy that out. Come over here. How much are they replacing? Yeah, they're putting that right here. A slice of names. Alright, so that's interesting terminology to say a slice of names. They're not saying an array of names. So I wonder if there's something special going on there. Like something a little different than what I might have expected. Alright, so now we're going to change out the hello call for the greetings call, the hellos call. And then we still do the same error checking because that error message is getting propagated from hello. And then format print line messages. So we just changed that to be a plural there. And then if we go run dot. Alright, so it handles like getting a representation, like in Python, the repr. So like we have it tells us it was a map, and it has Darren, and then there's like, you see that colon there, indicating this is the key, and this is the value. What's interesting is there's no indication where the value ends and the next key begins. That's a little interesting. They would just run together. If you were just looking at this, like if they were just like strings that had spaces in these keys, you wouldn't be able to tell the difference. It's a little interesting. Would have felt like they would have had a more clear way to print that out. But okay, we're getting distracted. So we've gone through that step. We now know how to make a loop to go through an array. Which I think is about all we need, because we're going to be doing a two-dimensional array. The tricky bit is, how do we create a two-dimensional array? We might have to Google that. I don't feel like we're going to see that anytime soon. Because we know how to create an array, a slice. And that's how we create a slice right there. So yeah. I'll have to figure, because like, how do you type that? How do you type an array of arrays? And then how do you create a slice of slices? Because we're going to want to initialize it. Alright. All the little things you got to figure out. Alright, so now add a test. We're not going to bother adding a test, but we'll look at it real quick. Because Go does come with its own testing stuff built in. And alright, so like in the greetings directory, so inside our package we created for the greetings module, we create a file greetingstest.go, ending a file's name with _test, tells go test command that this file contains test functions. And so then they're importing. It's part of, even though we're in the greetings test file, it's still part of the package greetings. And they're importing testing, they're importing regex, some name, must compile. Oh, okay, so they're looking for backspace name backspace. Blank space. I'm trying to think what the slash b. The b is in regex. So then they're calling hello. They're capturing the error in the message. If the regular expression doesn't match the string, so not, so we're using the bang to represent not, like C, C++, JavaScript. Like, it's a very common syntax for Boolean not. And then we've got that C like or, logical or. And then we've got the C like bang equals for not equals. We saw that a little while ago. And then we're using fatal F. And fatal F, where is, oh, okay, this is coming from testing. Right? Yeah, T, testing, T. It's coming in there. I don't know what the star means. Maybe they'll explain that down below. So I'm assuming there's a fatal, where you can just die with a message. And then there's fatal F, which lets you use formatting. Like you can pass in the variables here. Right. And then they added testing for test for hello empty. So that's testing if you pass in an empty name. And that should turn error message. It's testing to make sure error message is empty. If it's not, we're gonna have a fatal. Or if the error is nil, because it should return an error. All right. So let's see. Does it explain the star? That's what I want to know. I don't see it explaining that. Alright, so it's pretty simple, like go test. Very basic. Very simple. Compile, install the application. And then to a compiler, you just call go build. That's pretty basic. That's pretty simple. So if we just come over here and we do go build, and then we can do dot/hello, boom, it worked. There you go. Pretty straightforward. And like now, if we ls, we see we have hello, and if you cat hello, it's gonna be a bunch of gibberish. Check it out, gibberish. Boom. Go to new line. There we go. So what next? Now I think we're gonna go ahead and try to make our own something or other. Yeah, let's ls rm-rf greetings, hello, boom, and then we're gonna maker Tic-Tac-Toe, and then we're going to Tic-Tac-Toe, and what is it? It's go mod init Zech.codes and Tic-Tac-Toe. Create a new module. And then let's do this. Tic-Tac-Toe.go. And then can I do code Tic-Tac-Toe go? Yeah, I don't have code installed. Oh well. So we can close this, we can close that, we can go here, and we see we created the Go file. Package main. And then we're gonna do func main that, and then Why are you complaining? I don't understand VS Code. Import. Well, let's just make sure things are working. We're gonna import format, and then we're gonna do format dot or how did oh no, I already forgot how to print. Bumped print line. Why does it not like us? Package main. Oh. Like that. Not curlies. There we go. It's still complaining left and right. Oh, lowercase l? There we go. Now if we do go run dot. Yay! It worked. Alright. So there we go. We've written our first Go program from scratch. No copy paste. Now what do we do? Right. So we're gonna have our board. We are going to need to Google go create 2D array. Go multi-dimensional arrays. So I think we can do board equals 3 string and then you know what would be better? Board equals create board. There we go. And then we need to create that function, create board, and it returns a 3x3. Oh, come on, VS Code, be smarter. String. Go. And then we're gonna do var board, and then 3x3 string, right like that. And then we're going to do for I range 0 to 3. How does that work? Oh, okay, I see. You don't have to use range. You can do a good old-fashioned equals. So we're going to do y equals 0. Y is less than 3. Y plus plus. More of a C style. X, not Y. X plus plus. And then we do board Y X. Hit the right buttons here. Equals empty string. And then we return board. Right like that. Super duper simple. We have lots of complaints. What? Oh, I see. I see. I see. Can I do that? Can I do that? I can do that. Cool. Now, why is this complete? Declared but not used. Alright, cool. So now we have our board, right? Then we can run. We're gonna pass it to board. That winner, and run is gonna return a winner. Now, run is gonna be our game, right? Or I think we're gonna do this. Oh, actually, you know what? It's just like this, I think. I think this is how you do an infinite loop. If winner is not equal to break dot print line and we'll just do that. Winner. Is this actually, will this let me see? Print and F. There we go. Percent V has won the game. Actually, top. And then we do winner. Else if we'll do that. Then we got to put a condition. Hi. Dot printf. Oh, we don't need printf. We can just do print line. And we're gonna actually change tie to draw. But you don't actually tie, you both lose. Like, no one reached the winning condition. Alright, so there we go, break. And now we have to create the run function. And that's going to take a board of 3 by 3 string. And it's going to return string or bool. And that's going to have player I actually in the instructions. So we're working on the Summer of Code challenge. Player 1 gets X's. Alright, so we're gonna do X, player equals X, and then we're gonna do 4 actually it's turn 0, turn less than 9, because there's 9 spaces on the board, so we're only gonna see 9 turns. Turn plus plus, turn empty string and true. Alright, now print board. Print board. And this isn't going to return anything. Now we have to do this right here. So we'll just take that. Actually, we don't need this because it's only a 3x3 board. We're not gonna kill ourselves. Print line print f. Print lnf. We'll try it. We'll see if it works. So we're gonna have even better. You know what we're gonna do? No, you know what? We're gonna do what we're gonna do. We're gonna do nothing. All right. We're gonna do %e. I'm gonna assume this is the style. And then if y less than 2, we're going to dot print line 3 1 2 3 1 2. All right, there we go. So we're not going to print that at the bottom. I don't want to run this just yet because it'll be an infinite loop if I do. Print board. XY. I'm curious if this will work. Get player input player. And actually this is going to be a number. We're going to do player 1 and player 2. The player, so now we got to get player input. Func get player input player int. It's going to return int int. We're not in Python right now, huh? Or we're going to do an infinite for loop right now. Now, how do we get player input? Go get user input. How to say input, print line, scan line. Just curious. So I don't think we're actually going to need the loop. Awesome. Var xy int print line or printout. Player. D. Enter the words on your next. Oh, actually, we do need to have a loop. Because we need to pass board. We go beard. We're gonna pass the beard in. Alright, we need to pass in the board. It is 3x3 array of strings. Enter board on 4. And this is going to be an infinite loop. How do I move a line up in VS Code? That's how. Alright, cool. Players ID, enter the chords of the next play. Dot scan. And then we're passing it a reference of X. Alright, just trying to make the instructions clear for the user. And Y. There we go. So that gets us our two values. If board Y X is not equal to empty string, or equals empty string. This is what we're gonna do. Turn X Y. Where did you get your from? Oh my goodness, I am writing Python over here. And then otherwise, dot print line. That space is already taken. Pick another. There we go. All right. So now we've got our X and Y. Can we finish this in the next 22 minutes? I'm probably gonna stick around until we get it done because, like, this should be pretty easy to get done. We might run into some weird little issues. Google will help us with those. It shouldn't be too hard. Not hard at all. All right. So now that we have the X and the Y, player values. I'm gonna create a mapping here. Well, not really a mapping. It's just gonna be an array. To string, and it's gonna be X. Oh. What? What is it complaining about even? I know. We don't need to go on a new one. But alright, there we go. And then I'm gonna actually change that to 0, get player input. We actually goofed up here. We need to pass in player and +1. Because we're going to give it 0, and it's going to put 1, or we're going to give it 1, and it should put 2. That space is already taken. Pick another. So now we have the player. We can look up their player pieces. That's what I'm going to call that. And then we can do board. Now, the question here is going to become, is this passing the array as a copy, or is it passing it as a reference? I have a feeling it's passing it as a copy. We'll find out in a minute, won't we? I think that's what the star does. So then we do y, x equals 0. Not 0. Player pieces. Player. And then we do player equals player plus 1 mod 2. That'll cause it so like when it's player 1, player will be 0, right? And so then we'll add 1, and it'll go, now player will be 1, and we'll do mod 2, and that's still 1, right? But then when the player is player 2, player will be 1, right? We'll add 1, it'll go to 2. 2 mod 2 is 0. So it's going to toggle between the two players. Alright. So what's next here? I'm going to add a break here. Right? We're going to go run this. Ooh, excuse me. What does that even mean? What does missing mean? First off, printf doesn't give us a new line. If I do that, this highlight does not. Or it does, never mind. I see it. You don't want to go onto a new line there. Print line, we need to put a new line here. So now if I run this again, oh, you know why that says missing? Duh. Can I do this? Board Y. Does that splat? Does that not splat? That doesn't splat. So we have to do board Y 0, board Y, whoops, Y 1, board Y 2. Now that won't say missing. Well, why is it complaining? Ooh, right. They're not digits, they are strings. I don't know why I thought they were digits for some reason. Kill this thing. There we go. We have too many spaces. You know why? Let me... Still have too many, but that'll be fine. And why do we have too many? 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, I know. I know why we have too many. Where do we build the board? Build the board is print board, create board. Okay, it needs to be a space. If board equals a space, and that'll cause this to look correct. And then we can add in missing spaces. 1, 2, dashes 3. And then if we run that, there, our board is correct now. Cool. And let's do this. Make things look a little bit more. Now if we do that, see, run it, there we go. It looks a little bit better, I guess. Alright, we're making progress, a little bit at a time here. Very cool. Alright. So we got that working. And now if I do 1, 1. Player 1, enter the chords of your next play. X, Y, each should be, alright, 1, 1. Then if I do 0, 0, I do need to. Cool. This is actually working. 1, 2, and then we do 0 or 1, 0. My X and Y are backwards. All right, so we'll have to address that. So then if my X and Y are backwards, I need to do 1, 0, put it where I want. That space is already taken. Pick another. So I need to do 0, 1. There we go. And then we need to do, if 1, 0 was taken, that means this spot is taken. So we want to do 2, 0. There we go. So now we got tic-tac-toe for O. Okay. We just need to flip these right here. X, Y, and then we're going to kill it. Boom. And now if I do 1, 0, and then we do 0, 1, or 0, 1. Okay, so it waits for the next number. What happens if we enter? Weird. All right, cool. So we've got that much work. We're able to place pieces on the board, and we're able to detect if someone else has already placed there. And we did determine that this array is being passed around by reference, because we're making changes to the board inside of, well, actually, maybe it's not. It might not actually be being passed around by reference. The reason why I say that, is because we're only modifying board inside of run. We're not using it we're not modifying any rows. All right. Win check for is winner, and then we pass it board, and then funk is winner board 3 3 string. We don't have to pass in the player. The reason why is because the player who just placed is the only one who could be winning right now. So if we find any row or any column where or any diagonal where there is a winner, where there's a 3 in a row, if we find any 3 in a rows, then we know the current player placed in that row. And so they are the winner. So we don't have to let it know anything else. All right, so we can do bool for y is 0, so we're going to check the rows. Check rows for 3 in a row. Y equals 0. Y is less than 3. And y plus plus, right? If board 0, we're going to do this. For x is 0, x is less than 3, and x plus plus. I'm actually going to do 2 checks here. We're going to use the same loop to do the same thing. So what we're going to do is we're going to actually change this to I and J. And the reason is because they're not actually going to be X and Y. They're just arbitrary indexes into our board. If all match equals false, or equals true. And actually, this will only be 2, right? Okay. And then we will do if yeah, all right. So if board I J equal is not equal to board I 2, all right? If it's not equal to that, so what we're doing is we're comparing the first 2 in the row with the last one in the row. And we don't have to actually do all match. We're just comparing to see if the first 2 match the last one. If either of the first 2 don't, we don't have a winner. So we return false, or false, like that. And then we're going to do or board J I is not equal to board 2. Now we're doing the columns, or we're doing the rows now. We just did the columns. And then J. Actually no, I. Right? Yeah, that makes sense. Okay. So if either of those is not equal. Oh wait, hold on. Maybe this doesn't work the way I thought. We're gonna do it simpler. We're gonna just do simpler. If we're gonna do this. This is what we're gonna do. So if is 3 in row. Yeah. It's 3 in a row. And then we're going to do board I 0. Board I 1. And board I 2. 4 is 3 in a row. Board 0 I. Board 1 I. And board, there we go with our beard again. Board 2 I. All right. Turn. True. So that's going to do the horizontal and the vertical. Checking each one at the same time. Nope, it didn't like it. All right, whatever. And then we've got to check the diagonals. Return is 3 in a row. Board 0 0. Board 1 1. Board 2 2. And then 4 is 3 in a row. Board 2 0. Board, right? I'm trying to think. 0 0 1 1 2 2. 2 0. Yeah, right. And then we're gonna do 1 1 because that's the center. And then we're gonna do board 0 2. There we go. So now that'll check the diagonals. Funk is 3 in a row. Space 1. And that's gonna be a string. Space 2 string. Space 3 string. Cool. If space 1. What's the space? Or action. Equals. Alright, so this is how we're gonna return space 1 equals space 2 and space 2 equals space 3 and space 3 is not equal to a space. Alright. So if they're all equal and none of them are a space, it's a 3 in a row. Okay. I think that works. Is winner, win, if, win. Oh, we don't even need to store that in a variable. We can just do if is winner. Return player plus 1. We'll add 1 to the player. And then it's a tie, false. No, false. There we go. Why are you complaining? Oh, I see. We're gonna make that an int. And we're gonna make that a -1. Or we're gonna make it a 0. There we go. Okay. If winner is not equal to 0, get rid of that. And we don't even need this loop anymore. You can get rid of this line. No, 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 no. There we go. Get rid of that line. That. There we go. So now we create our board. We run the game. We're going to rename this to play. Play. Oh. We play, and then we get back a winner or a draw. If winner is not equal to 0, we're going to switch these. Right like this. Right like that. And then we can just make this an else. I like that positive condition. If draw. The game has ended in a draw. Else player 1. So we need to have player 1 has won the game. Player 2 has won the game. Alright. Pretty cool. Alrighty. I feel like it's gonna work. So let's put it right in the middle. We're gonna put it right in the corner. Let's put it at 1, 0. And then we're gonna put it at... Did I? I think I screwed it up. Oh well. We're gonna go at 0, 1. Oh no, we've got a bug. When we get the player's input, get player input, we check it in a different way than we place it. And I feel like I had the placement correct, and I just confused myself somehow. So we're gonna do this back to the way it was. And kill it and then restart it. So we're going to go back in the middle, and then we're going to put this at 1, 0. 1, 0 should be right here. There we go. Alright, so we got that correct. So then we're going to go at 0, 1. There we go. And then we're going to put this at 0, 0. And then we're going to put this at 1, no, 2, 1. Boom. Player 1 has won the game. Now let's just check and make sure player 2 can win. Let's put this at 1, 1. We're going to put this at 0, 0. We're going to put this at 2, 2. We're going to put this at 0, 1, or 1, 0. There we go. We're going to put this at 2, 1. And then we're going to put this at 1, 2. That was stupid. I don't know why I did that. And then this goes at... should be at 2, 0, right? Player 2 has won the game. And now let's see if we can't get a draw. Let's make sure the draw works. Alright, so we're going to go 1, or we're going to go 0, 0, 1, 0, 2, 0, and then we're going to go 0, 1, and then we're going to go 1, 1, and then we're going to go 2, 2, and then we're going to go 1 or 2, 1. Just trying to make sure nobody wins. And then we go 0, 2, and then we go 1, 2. Boom. The game has ended in a draw. All right, cool. Very, very cool. I am going to do this. We're going to add a new line, right, like that. That's won the game. So now, if we do it one more time, We're gonna go 0, 0. We're gonna go 2, 2, and then we're gonna go 1 or 0, 1, and then we're gonna go 2, 1, and then we're gonna go 0, 2, boom, and there we go. Now it separates it out a little bit, and I do want to have that slash in there, so this way it gets rid of that little percent there. All right, cool. So there we did it. We have created Tic-Tac-Toe in Go, starting from pretty much 0 knowledge of Go. Pretty neat, and it took just slightly over 2 hours. At 7:06 p.m. We started at 5 p.m. We did talk for a little bit at the beginning, so not bad. If anybody is watching right now, feel free to ask any questions while I add this stuff to Git. Yeah. So yeah, if you don't know anything about the Discord server, if you've been watching or you watch us in the future, I run the beginner.code's Discord server. And it's basically a community to help people learn how to code, help people with their projects, help people get better at coding. And we love to have new members. We've got 8,200 people. We've got a great help system, so if you ask any questions, it won't get lost in a deluge of questions. You can pick a channel. You get a channel, it's got whatever language, topics you need help with. You just provide the information you have, any error messages, any files, any code that you have, and someone very friendly will come and help you out. We're not always the most quick, like we have mostly people in Europe and North America. So sometimes there's times a day where it's a little more dead than others. There's not much we can do about that. People have jobs, people have lives, people go to school. But yeah, it's a great community. We have a lot of fun. We're super friendly. We love new people. So yeah, if you're not already a member of the beginner.code's Discord server, make sure you check out the link in the description down below. If you want to talk to me, reach out to me. I'm on Twitter. I check my Twitter frequently, all the time, most of the day. And you can also reach me on Discord, which is where I'm most active, where I talk the most and hang out with people the most, on the beginner.code's Discord server the most. So yeah, check me out there. You can also reach out to me in the comments below. If you would like me to talk about anything, do anything, anything you'd like me to do in a stream, maybe even a YouTube video. I haven't done any just straight up YouTube videos on any topics, but I'm not opposed to doing it. I'm willing to possibly try that out. I'm a little bit busy, but it is something I might be willing to do at some point. So let me know in the comments below. I would love to hear from you. If you have any questions, like I said, let me know here on Twitter and wherever you might find me. Yeah, if you want to check out the code that I have for this project, it'll be on GitHub. The link is in the description down below as well. So yeah, and I would love it if people would check out the Summer of Code, the beginner.code Summer of Code, at soc.beginner.codes. And it's just a fun little thing we're doing this summer, where we're doing like a weekly challenge, and you can submit a blog post, you can submit a video, you can submit a code submission, and people can vote on them, like show off, and people can see the code, and there's a leaderboard. So yeah, we'd love to see your code submission there. And our first Go game. Not add, create. Our first Go. We're screwing things up right now. Okay, and then what did I do wrong? Git commit -m. Well, that was weird. Interesting. Never had that happen. Yeah, alright. And then git push. Alright, cool. So there we go. That is up on the GitHub. And if we go to GitHub, that is on my YouTube GitHub organization. One committed to me. There we go. Here it is. And you can see I've got a license, I've got my Git ignore, and I've got my Tic-Tac-Toe project. If you want to play that, just jump into the... I thought I told it to create a README. I must have accidentally deleted that. So let's create a README. Zech's first Go program. And I had, let's see if we can find it. Was my first, this was my attempt to learn Go while coding Tic-Tac-Toe. Streamed live on YouTube. And we'll make that a link. Go. I think it was a great success. Running on the repo in your terminal. Run go run dump. You'll need to make sure you have Go installed before you do. Learn how to do that. And let's go grab that link for and go get started. We'll link there. And then you go read me. Save. And git add git commit -m add readme push, and then we come over here and nothing happened. Did I not push? Oh, you know what? We're in the wrong directory. To move readme, it's there. What happened? All right, so we're gonna git commit -m add git push. Haha, there we go. Zech's first Go program. All right, there we go. I hope y'all had fun watching that. I know I had fun getting to learn Go a little bit, getting to play around with the language some, and just getting to understand like some of how it works and like how things function, and syntax, and how packages work. Getting to understand how the command line tools work for Go. Go is great for those command line tools. Those command line tools are actually really powerful out of the box. It's a very nice developer experience feature of the language. There are a few little weird quirks of the language, in my opinion, just my personal taste. But yeah, I hope you enjoyed that. I hope you learned something. And I'm live just about every Wednesday at 5 p.m. Eastern Time and Sundays at 3 p.m. Eastern Time. Most of the time, I do spend time with my family a lot of Sundays. And sometimes I'm just not able to stream. So yeah, I will see you most likely this coming Sunday.